In this video, we are going to be learning about Kolbe's electrolysis and Hell-Volhard-Zelinsky reaction. So Kolbe's electrolysis was actually taught to you in grade 11. So I'm just going to do a recap of just the equation alone. So basically, the alkali metal salts of carboxylic acid. So we are having a salt of carboxylic acid is being decarboxylated on electrolysis, is undergoing decarboxylation to form a hydrocarbon. And this hydrocarbon is going to have double the number of carbon atoms than the alkyl part of the carboxylic acid. So let's take, for example, we have sodium salt of acetic acid or sodium acetate. So 2CH3COO minus Na plus is undergoing in water. So it's an aqueous solution. It is undergoing electrolysis. Okay, and this gives us ethane and carbon dioxide and hydrogen and sodium hydroxide. So this reaction was taught to you in detail, where you learned as to which which particular substance is formed at the anode, which is formed at the cathode last year. This year for now I'm just telling you the basic reaction. The salt of carboxylic acid is in the aqueous solution and it is undergoing electrolysis to give us a hydrocarbon. And the hydrocarbon has twice the number of carbon atoms as the alkyl part of the carboxylic acid. So here you have CH3COO minus, this is sodium acetate. It is undergoing electrolysis in aqueous medium. Because of that, we've written H2O. This leads to the formation of ethane. So this only has one carbon atom in the alkyl part, but in the product the hydrocarbon has two carbon atoms, and carbon dioxide, hydrogen and sodium hydroxide. So that is Kolbe's electrolysis. Do not confuse this with Kolbe's reaction. We learnt about Kolbe's reaction in phenols, reaction of phenols. So that's different than this one. The next one we are going to be learning about is Hell-Volhard-Zelinsky reaction or HVZ reaction. But I'm going to spell the whole thing out. Hopefully I do it right. So what happens over here? Here we are having a carboxylic acid with at least one alpha hydrogen. So the alpha hydrogen basically means, suppose you have CH3COOH. This carbon is the alpha carbon. So these hydrogens are alpha hydrogens. It's similar to what we learned for aldehydes and ketones. So carboxylic acid with at least one alpha hydrogen. So I'm just going to write alpha H. Okay, it reacts with a halogen, right? It could be a Cl2 or Br2, so it can be a chlorine or bromine in the presence of a small amount of red phosphorus, and this leads to the formation of an alpha halocarboxylic acid. So alpha halocarboxylic, to put it very simply, one of the alpha hydrogen is getting replaced by the halogen atom. That's all. That posh name is alpha halocarboxylic acid. So basically only one of the hydrogen atoms, alpha hydrogen atom, is getting replaced by a halogen atom. So let's take the example, or write the general reaction. So CH2COOH. These are going to be the two alpha hydrogen atoms. Now let's assume it is undergoing a reaction with X2, and X2 can be chlorine or bromine and red phosphorus. And the second step, this has to be the first step, I'm sorry, is addition of water. So basically one of the alpha hydrogen is going to get replaced by a halogen. So RCHXCOOH, and this This is called alpha-halo-carboxylic acid. So this R can be a hydrogen, then it will just be this, the starting material would have been ethanoic acid or acetic acid, or it can have any number of carbon atoms. That R we know. X is either a chlorine or it can be bromine. So this is all about Hell-Volhard-Zelinsky reaction. So in Kolbe's electrolysis, the salt of carboxylic acid in aqueous solution of salt of carboxylic acid is undergoing electrolysis to give rise to a hydrocarbon. This is the detailed reaction. Hell-Volhard-Zelinsky reaction is an alpha hydrogen containing carboxylic acid is undergoing a reaction with chlorine or bromine. Oh, I'm sorry, this had to be Br2. Chlorine or bromine in the presence of red phosphorus to give us an alpha halocarboxylic acid. In simple words, an alpha hydrogen is getting replaced by a halogen. That's it. With that, we're done with these two named reactions. In the next video, we're going to be talking about Gabriel-Thalhamide synthesis.